Hello everyone, this is Asta Trivedi and today we will discuss a topic related to cloud computing, that is edge computing. Before starting the presentation, is it fair to say that edge computing will replace cloud computing? After cloud computing rocking the IT world for the last decade, now it is time that edge computing is picking up pace as we are seeing the advent of IoT and 5G network. So let us find out what is cloud computing first. Cloud computing is the method of using remote servers that are hosted on internet instead of physical server to store and process data. What used to happen is that data from the particular device is sent to the cloud provider data center for processing. Uh, After the processing, it comes back to the particular system. It was good for a while, but now, as we are moving into real time data and IoT application, this processing needs to be very quick. And that's where edge computing is now coming into picture. So let us find out what edge it provides over cloud computing. So what is edge computing? Edge computing is a range of networks that bring computation closer to where the data is being generated and processed. We have data sources all over us. Even our mobile phones are data source because app keep generating data that can be captured and processed. Only apps are installed on your phone. The instruction you fire on it are getting processed outside of it on a computational device. So the idea here is to bring the computation as close to the source as possible. Edge computing has gotten really popular because its power of minimum latency, which means that computation is done quick. It is especially useful for streaming, be it online streaming service like Netflix, for live streaming like Instagram Live, live events on YouTube, or streaming sports event or various platforms as they happen in real time. We have come to expect as they a certain standard in quality of streaming without lags and delay. Even someone from a different geographical location, all of this is happening over cloud. Let us know the architecture of the edge computing. Basically, we have three different layers in edge computing. First is the cloud data center. Second is the edge gateway server, and third are the edge clients. So what happened in edge computing is that there is a smart device or a edge client device which is installed on all these systems which record all different kinds of data which is being generated by the different devices and then it process that data. It has some sort of intelligence built in within and has some storage capacity as well. Then it processes the data and then for the higher workload it send it to nearby gateways. What is the difference between sending it here in Edge Gateway versus sending it directly to the cloud? It is that your Edge Gateway would be physically located very near to your device, so that reduce the latency and increase the processing power. That's why all these gateway physically closer to all these different systems. Now let us discuss the example of edge computing, security and surveillance. A security system is suppose if you are a property owner of a single property, then the security system are simple. You may have a couple of cameras at the front door and in your backyard, and it seems live visual. This is easy to track and process whether or not there is any motion within the area. This raw footage is transferred real time from source X to source Y by internet and is going to consume a lot of internet bandwidth, which may be completely unnecessary. This will naturally overload the computing server where the raw footage is being dumped for processing and cause computing delays. We cannot expect the same speed that you would expect from a streaming service because sometimes in such cases the computing may take minutes or even hours. This could work to your detriment because by the time the footage of something untoward happening getting to you, the damage may already have been done. Now consider a situation where server by running an algorithm has a capability to only select the footage that have motion in them. So if there is a layer between the data capturing device, in this case the camera, and the computation service like preface, it can do a pre-computation checking for the motion within the footage or only sending that footage to the main computational service, after which if there is an issue the security alarm is triggered. This is there and whole process could save a lot of load from server while also using less data bandwidth. The main benefit of it is that streaming is flawless and without any delay or lag. This process of building a logical layer at the source where pre-computation happens before the data is moved to the final destination is basically premise of edge computing. Difference is security. Edge computing need a comprehensive security strategy because there is a pre-computational layer at the source which could potentially be manipulated and is a prone to malicious activity. This could lead to a break in information transfer. Now, consider the second example, that is autonomous vehicle. Edge computer enable autonomous vehicle because they can gather the data produced by vehicle sensor and camera, process it, analyze it, and make decision in just a few milliseconds. Third example is smart agriculture. Edge computing solutions are deployed to gather information from sensor used to monitor the weather condition, quality of soil, uh, wetness of soil, the sunlight, and other information that vital to improve the growth of the crops. Now, last example is predictive maintenance. Edge computers are often used by organizations because they can gather information from various sensors, camera, and other devices. They can use that information to determine whether the component or certain machinery is failed or not. Now, let us discuss the difference between the edge and cloud computing. First feature of difference is location of processing. Processing is done at the edge of network near the device that generates the data in the edge computing, whereas data analysis and process are done at the central location, such as the data center and cloud computing. Bandwidth requirements. Low bandwidth is required as data is processed near the source. In edge computing, whereas higher bandwidth is required as compared to edge computing as data must be transferred over the network to the central location for the processing. Cost. Edge computing is more expensive as specialized hardware and software may be required at the edge, whereas cloud computing is less expensive as users only pay for the resources they actually use. Scalability for edge computing can be more challenging as additional computing resource may need to be added at the edge. Whereas in cloud computing, it is easier as user can quickly and easily scale up or down their computing resource based on their need. Applications that require low latency, real-time decision making such as IoT device, autonomous vehicle and AR/VR system uses edge computing, whereas applications that do not have strict latency requirements such as web application, email and file storage use cloud computing. Data security can be improved as data is processed near the source and is not transmitted over the network in edge computing. Data security is more challenging if data is transferred over the network to central location for processing in edge computing. Pros and cons of computing, edge computing. First, we will discuss the pros, that is low latency, reduced bandwidth as data is being processed near the source, improve data security and privacy because data is not transferred to the data center. It improves the security. Offline functionality, decentralized infrastructure. The cons for edge computing are limited resources, higher upfront costs because specialized edge system resources are required for creating an edge computing atmosphere. Security management challenges, though data is being processed near the source, but unauthorized breach of data can be take place near the source as well, hence it concerns the security. Software compatibility issue. There are many devices over the network which need to be compatible to each other so for the functioning of the edge computing. Limited scalability, as scalability will require more computing resources. So these are the some area where we have compute edge computing playing an important role or will play an important role in the coming time. Now you would see next 10 year or so. So is it fair to say that edge computing will replace cloud computing? I don't think so. It would never happen because cloud computing would always be the parent and edge computing would be a subsidiary of it. Both would coexist, both will enable faster cloud adaptation as a whole. That's all for edge computing. Thank you.